Hi everyone. Today we'll discuss solenoidal vector. What is solenoidal vector? You see, what is solenoidal vector? Del dot F equal to 0 is called solenoidal vector or operator. This is our divergent F equal to 0. It's called solenoidal vector. We'll give one example. We'll go for one example. Show that the given vector F is a solenoidal vector. F equal to 2x of yz of I plus 4y of zx of j g of j minus 6z of xy of k. F. So we have to show it is a solenoidal vector. Solenoidal vector means del dot F equal to 0. What is your del? I dou by operator. This is the operator. Operator is nothing but I dou by dou x, j dou by dou y, partial derivative, k dou by dou z. I dou by dou x plus j dou by dou y plus k dou by dou z. Dot product of f. What is f? 2x yz of I plus 4y zx of j minus 6z xy of k. Now I dot I is 1, so dou by dou x of 2x plus yg. J dot j is 1, so dou by dou y of 4y plus zx. K dot k is 1, so dou by dou z of xy minus 6. Now with respect to x you are doing, this is derivative of x is 1, partial derivative, dou by dou x is 1, 2. This is 0. If you are doing with y, going with y partial, this is 4y is 4, this is 0. And if you are doing with z, xy, this is 0, minus 6. So minus 6. What is our conclusion? What is our conclusion? 6 plus 6 minus 6. 2 plus 6 is 0. That means del dot f equal to 0 implies f is a solenoidal vector. One more example. One more example of the same type. So if f equal to x plus 3y of I plus y minus 2z of j x p z of k is a solenoidal vector point p. Point p. What is p? So solenoidal vector means del dot f equal to 0, it is given. So this is I dou by dou x, j dou by dou y, k dou by dou z. Dot product. What is our f? X plus 3y of I plus y minus 2z of j x pz of k. So equal to 0. Now I dot I is 1. So dou by dou x of x3y, j dot j is 1. You see dot product. I dot I is 1. Remember, J dot j is 1. K dot k is 1. What is I dot j? J dot k or k dot I or j dot I or k dot j or I dot k, all equal to 1, 0. So dou by dou y of y minus 2z, dou by dou z of x plus c should be equal to 0. This is from the definition. With respect to x we are doing, so this is 0. Derivative of with respect to x we are doing, so dou by dou x is 1. This is 0. Dou by dou y is 1. This is 0. This part is 0 because with partially differentiating with respect to x, partially differentiating with respect to y, partially with respect to z. So 2 plus p equal to 0 or p equal to minus 2 because it is solenoidal vector. One more example. This is finding the value of p if the given vector is solenoidal. Next, one more. If del dot f equal to 0 and f is a solenoidal vector, find n if f equal to r to the power of n vector r. Find n, you have to find n if f is this, f is a solenoidal vector. Solenoidal vector means what? Del dot f equal to 0. We have to find n and f is given by r to the power of n vector r. Okay, let's go one by one. Very easy. See here. You see vector r is given by xi plus yj plus zk. Vector r to the power of n. You see, this is mod of r. Vector, this is r is mod of vector r. This is under root of x square plus y square plus z square, and dou r by dou x is x by r. Dou r by dou y is y by r. Dou r by dou z is z by r. And suppose vector r, dou r by dou x. If you are going with dou r by dou x, it is I. Dou r by dou y, vector I, it's j. Dou r by dou z, it is k. Now, so what is given? Del dot f equal to, so let's go with the left hand side first. Del dot f. What is del? I dou by dou x plus j dou by dou y plus k dou by dou z. Dot product r to the power of n vector r. R to the power of n vector r. So this I am writing I do one more step, dou by dou x, j dou by dou y, k dou by dou z. Dot product r to the, what is vector r? Xi plus yj plus zk. So now I dot product, I dot I is 1. So dou by dou x r to the power of n x. Similarly, dou by dou y r to the power of n y. Dou by dou z r to the power of n z. So now this we can write summation for all three dou by dou x r to the power of n x. Now summation as it is. Now the product rule. What is the product rule? X as it is, dou by dou r of r to the power of n plus r to the power of n is dou by dou x by dou x. X r to the power of n is n r to the power of n minus 1 dou r by dou x plus r to the power of n. See here. Just now what we did, dou r by dou x is x by r. Dou r by dou x is x by r. N r to the power of n minus 1 x. Dou r by dou x is x by r. And this is summation if I take r to the power of n. And this is n r to the power of n minus 1 x square r to the power of minus 1. So this is n r to the power of n minus 2 x square summation x r to the power of n. And you see here this thing, summation. See here one small thing, n r to the power of n minus 2 outside summation x square. Use summation x square means x square plus y square plus z square. It's nothing but r square. So this is n r to the power of n minus 2 r square plus this is how many times? This is with x square, this is with y square, this is with 3 r to the power of n. So this will become n r to the power of n plus 3 r to the power of n. Now n plus 3 r to the power of n. So what the formula we have? Del of f. Del of f should be equal to 0 because it is solenoidal vector. So that means n plus 3 r to the power of n should be equal. R to the power of n cannot be equal to 0. N plus 3 equal to 0. N should be minus 3. N should be minus 3. That's it. We got it. Del dot simple. Del dot f equal to 0. We are not doing anything different. So problem number 4. Show that del dot r by r cube equal to 0. Or you can state this also, r by r cube is a solenoidal vector. Show that or prove that. R by r cube. Vector r by r cube. This is vector r. This is the modulus of r. Dimar. Some teacher they call dark r dimar. So what is the formula? Del of vector r by r cube should be equal to 0. We have to. So left hand side, del of vector r by r cube. What is your del? I dou by dou x, j dou by dou y, k dou by dou z. Dot product vector r is xy, yz plus zk by r cube. So this will be I. So this goes with this goes with this goes with this. So I dot I is 1, dou by dou x of x by r cube, dou by dou y by r cube, dou by dou z of z by r cube. So now I am writing just summation dou by dou x of x by r cube. Now summation keep as it is, 1 by r cube as it is, dou x by dou x. X as it is, dou by dou x of r to the power of minus 3. So now dou by dou x is 1. So summation 1 by r cube, summation x as it is, minus 3 r to the power of minus 3 minus 1, dou r by dou x. So this summation will be 3 by r because it will be coming with x, y, and so this will be 3 by r cube minus 3 r to the power of minus 4 outside x dou r by dou x is x by r. X by r again r if you take outside minus 3 r to the power minus r if you take r to the power of minus y summation x square. You see summation x square means x square plus y square plus z square which is same as r square. Summation x square is r square. 3 by r cube minus 3 r to the power of minus 5 r square. Because summation x square has become r square. X square plus y square, this is r square, this one. So this will be 3 by r cube minus 3 by r cube. R to the power of minus 5 plus 2 is r to the power of minus 3, which if you take to the denominator. Same minus same equal to 0. It's equal to 0. So what does it mean? It means vector r by r cube is a solenoidal vector. Is a solenoidal vector. So we have done this. Any other problem do you have? That's it. We are done with all types of solenoidal vectors. Okay. So what is solenoidal vector? Nothing. Del dot f equal to 0 or divergent f equal to 0. What is divergent? The operator. I dou by dou x plus j dou by dou y plus k dou by dou z dot product of whatever is the given function. Take the dot product, differentiate, simplify, answers always 0 is solenoidal. Or he will give some value, we have to find. Find P if it is solenoidal. Find K if it is, we have done this. And he says, show that R by R cube, whatever he says, only one thing we are doing, del dot F equal to 0. That's it. Thanks for watching. Please subscribe my channel and share with your friends.